Let us now study theory behind waves. To study this, let us consider two sound waves which are represented by two equations given by y1 is equal to a into sine of 2 pi f1 into t, and other wave given by the form y2 is equal to a into sine of 2 pi f2 into t. Here the two sound waves have same amplitude but different displacement. Now at any point the net displacement is given by y is equal to y1 plus y2. This is called as principle of superposition of waves. So let's write y1 once more. Y1 is equal to a into sine of, let's write in the form of omega 1 and omega 2, where omega 1 is called as angular frequency and y2 is equal to a into sine of omega 2 t. If we add these two, then y is equal to a into sine of omega 1 into t is a into sine of omega 2 into t is equal to a into sine c plus sine d is written as 2 sine of c plus d by 2 cos of c minus d by 2. Writing it here becomes twice into sine of omega 1 plus omega 2, so t is common, by 2 into cos of omega 1 minus omega 2 by 2 into t. What we get, and write this as y is equal to 2a into cos of omega 1 minus omega 2 to t term into sine of omega 1 to 2 into, which we can rewrite as y is equal to sum a to sine of omega 1 to omega 2 to t. This is the equation for displacement of the wave at a given point, where here a is equal to 2a into cos of omega 1 minus omega 2 by 2 t. This is called as, this a is called as amplitude of the beat wave. This represents the equation of a progressive wave. From here you can find the frequency of the progressive wave, which we can say as frequency of this wave is equal to 2 pi f1 plus 2 pi f2 by 2 into 2 pi is equal to f1 plus f2 by, so this is the frequency of this progressive wave. Now also the amplitude itself is not a constant. This itself varies with a given frequency. The frequency here is given by f of amplitude equal to will be omega 1 minus omega 2 by 2 pi into writing this term as it is, and to make it to be dimensionally correct we should bring 2 pi here so that it becomes frequency. Therefore the frequency amplitude is equal to f1 minus f by, as seen here, the frequency also, the amplitude also varies, which is not a constant because that is definition of a beat. In case of a beat there will be waxing and waning, or simple language there will be increase and decrease of intensity. Intensity would become maximum and becomes minimum also. That variation of frequency, that frequency is given by this form. Now find out when we get maximum intensity. To understand this, let's recall that A is equal to 2A in cos of omega 1 minus omega 2 by 2 T. From here, find its intensity. Then we know that intensity is proportional to amplitude square. Therefore, writing this in terms of intensity, just call I naught as the incident intensity of the waves, and from here we can say I resultant is square this term, then I resultant is equal to 4 times I naught into cos square omega 1 minus omega 2 into T. This we written A square as I resultant and 2 as it is A square as I naught. This term has been squared here. For maximum intensity, this term here is equal to plus 1. So the term in the bracket, the term in cos term, that is cos square of omega 1 minus omega 2 by 2 into T plus 1. If we take root on both sides, then cos of omega 1 minus omega 2 by 2 into T is equal to plus or minus 1. This happens if this term, that is this term is equal to 0, pi, 2 pi, etc. Mathematically we can say that cos of something is equal to plus or minus 1, and that something, which in this case is omega 1 minus omega 2 by 2 into T, is equal to 0, pi, 2 pi, etc. From here we can write what the time period would be. From here the time interval would be 0. Next would be, you need to bring this down, will be 2 pi by omega 1 minus omega 2. It will be 4 pi, that is need to this term multiply, take 2 on top, it becomes 4 pi. Bring omega 1 minus omega 2 down. So what we get would be 4 pi by omega 1, and it keeps on going. Let us find difference between any two time interval. So here we'll find difference between this time interval. In that time interval called as beat period, which you call as some delta t. Delta t would be 2 pi by omega 1 minus omega 2 and 0 will be 2 pi by omega 1 minus omega is equal to 2 pi. You can pull out 2 pi common here, f1 2. From here 2 pi gets cancelled. Therefore what we get here is delta t is equal to 1 by 1 minus f2. This is called as beat period, which is basically the time interval between two consecutive maximum intensity. Similarly, for minimum intensity, you can say cos square of omega 1 minus omega 2 with 2 into t is equal to 0. This happens if omega 1 minus omega 2 by 2, the whole term, by 2 into t is equal to pi by 2, 3 pi by 2, 5 pi by 2, etc. So we'll find what is time intervals. Again, if you multiply by 2 and bring this down, it becomes 2 pi by omega 1 minus omega 2 to 2 will be pi by omega 1 omega 2. Again here it will be 3 pi by omega 1 minus omega 2, because you can cancel 2 directly from here also. It will be 5 pi by omega 1, etc. Again here, if we find the time interval between two consecutive minima, then delta t would be difference of any two. Take difference of this and this time will be 3 pi by omega 1 minus omega 2 minus of pi by omega 1 minus omega 2. From here becomes 2 pi by difference of these two would be 2 pi by omega 1, and if we pull out 2 pi here comes 2 pi. If 2 pi is taken as common, then what remains here is f1 minus f2. From here we can again cancel 2 pi. Therefore, even here the beat period is pi. Pi gets cancelled. It's 1 by f1 minus f2. So the time interval between two consecutive minima is again same as the time interval between two consecutive maxima, called as beat period. If we take its reciprocal, it's called as beat frequency. We will call it as fb, that is equal to 1 by delta t, because frequency goes as 1 by time period or time interval, that is equal to f1 minus. Therefore, the beat frequency is given as difference of two frequencies. The beat frequency is beat frequency. You can say beat frequency is the number of times the sound intensity becomes maxima or minima. It's called as beat frequency. So it is simply given as difference of the two frequencies. In case of sound waves, the maximum intensity is called as waxing and minimum intensity called as waning. In case of sound waves, we use the words waxing and